Hi all, this is the week 4 lab for the one that's on tonicity and pH. Okay? I think we have 2, right? Then anyways, so there's what you're going to see when you open the assignment. You won't see the faculty materials, you'll see the student materials. You're going to have the lab formatted where you put in your answers and then the rubric. So let's look at that rubric first and see what's going on. So here's the rubric. As always, it's due on Sunday night. And you see that exercises are 1.25 each and observations is 0.75 and 0.5 for complete sentences, grammar, all that fun stuff. So I don't think you're going to need to cite anybody on this lab. And only 3 exercises, which hopefully isn't too horrible. I hate it when they get down to like 4 and 5. You're just like, oh. But then some of the hardest labs don't have very many at all. So let's go look at the formatted version. So as always, enter your title page. And then we scroll down to observations. I'm looking at the answer keys. So hopefully I don't forget to mention anything. So if you get a pause, deal with it. Here's the test tube, whatever your solvent is, how the potato was, and then if it was hypo or hypertonic. Remember, hypo is probably going to look crisp. If it's limp, it's probably going to be hyper. Okay, you'll go through that whole thing. And then water, you're going to want to know if it's turgid or non-turgid. Turgid is probably going to be hyper, and non-turgid probably hypo. And then what happened? What did you see? And then down here, we have our comparisons, just everything. What was your pH at the various times? What happened? Then data 4 was adding the drops. You'll probably see a point where suddenly your beaker 3 will change toward the end and your beaker 2 will probably change sort of in the middle. And then we graph it, which you just do. It looks hard and scary, but you just do a 2. Does it tell you down here? Yeah. You do a 2 for the buffer and inorganic and a 3. So say you have a 7 at 0 for both of them, which is what you do. You'll put a 2 and a 3 in here, and then you'll just do it, and it'll sort of look like a line chart because you'll see like do-do-do or do-do-do or maybe do-do-do, and that will help you see what's going on. It'll be a graphic display of the drops of HCl, okay? And then the case of the limp vegetable. They had fun. So how does it look? What explains this? Which we said the hypo, right? And what's behind that? And then what caused it? Discussion. Did it support or refute? Explain why your refrigerator does this junk. 2 types of tonicity. Explain. Suggest an experiment. So come up with an experiment. And then what kinds of cell environment conditions might cause tonicity? How's difference? Are we into turgor now? Now we're into turgor, so you'll talk about that. What was altered? Really, if I were you, before I started my experiment, make sure you, of course, you read the lab manual pages, and then I would go through and read this stuff too. And make sure that I had read all the questions before I actually started the experiment, just so I kind of knew what was where, because then you'll feel familiar with it. You'll be like, okay, so when I'm dealing with, you know, the 10% NaCl, that's going to be dealing with the turgor. It'll just make life easier. Da-da-da. Did the exercise support or refute your initial hypothesis? Where might be the turgor pressure adjustment? Which one is that? That's B under discussion. Yeah, so then you have your buffer, what's your pHs, what's happening, your discussion, did it support or refute, and then lab summary. So not too bad, a little scary because you are dealing with like actual things. I think you guys can do pretty well on this. If you do feel the need to add a reference, add an in-text and a reference, that's fine. I don't think you really need to for this one unless you want to define something, like with those experiments. If you want like an example, of course you could Google it. Just give me a reference if you do. Okay, I hope that helps. I hope you feel confident about pH and tonicity.